right, boys and girls, we have ourselves our open-ended. We're given this picture right here, and we're going to be given 4 parts to it. Make sure when you do these, you answer in complete sentences. If you can, you show all your work if it tells you, all of that good stuff. There are right triangles shown on the map. List 3 roads that form a right triangle. There are many answers to this, so I'm going to choose just one. I'm going to choose this right triangle right here. Okay? I'm going to choose that right triangle right there. So that right triangle is created by 3 roads. I don't have a lot of room here. I'll write it over here. Okay? Those 3 roads are Olive Street. If I knew how to spell olive, that would be great. Olive Street, Lincoln Avenue, and Franklin Lane. Again, there are many answers to this. Many answers to this. But I just chose these, and these are fine. You could have done Lincoln, Franklin, and Lemon, and that would have given you that one right there. Benson and Farm and Lincoln, and that would have given you that one right there. So when people have to grade these, they're going to be mad at you because there's all these possible options, but this one is a right triangle. And remember, a right triangle is a triangle with a 90-degree perfect corner angle. I don't care what the other lines look like, as long as one angle is a perfect corner like that, it is a right triangle. On to part B. There are roads that run parallel to Troy Lane. So here's Troy Lane right there, shown on the map. List all the roads that run parallel. Parallel means they're going to be lines that never touch each other. So if Troy looks like that, you want all the other roads listed that look like those perfect flat lines that go left to right. Okay, so since I don't have a lot of space in here, I'll write them over here again. The roads that are parallel to Troy Lane are Martin Lane, Franklin Lane, and Benson Lane. Okay, these roads will never run into each other. So Benson Lane, Franklin Lane, and Martin Lane. Okay? Okay. And again, if I were to draw that out, there's Troy, okay? Martin, okay, will never run into it. Franklin will never run into it. Benson will never run into it. Parallel lines mean they never run into each other. They never intersect. Jack claims that Farm Street is perpendicular to every road it intersects on the map. What does perpendicular mean? Well, perpendicular means if you were to have a line, perpendicular means it's going to create a perfect cross, like a plus sign or the letter T. And you're going to have 90 degrees everywhere. So let's find Farm Street. Here's Farm Street. Jack claims that this guy is perpendicular to every road it intersects. Okay? Which road proves that Jack claim is not correct? Well, Benson is correct because Benson creates like that plus sign. Oh no, but Lincoln does not do that. Lincoln does not give you that perfect, see, that does not give you those perfect 90-degree angles. So which road proves that Jack's claim is not correct? Lincoln Avenue. That's a letter N, isn't it? Yep, so let's erase that and pretend that never happened and turn it back into Avenue. Lincoln Ann. Ay, ay, ay. All right, last one. Explain why the map does not have a line of symmetry even though it is in the shape of a rectangle. Okay, a line of symmetry means that the left side and the right side looks exactly the same. If I were to try to cut you up and down, right, and fold you over like a piece of paper, these are not going to be the same picture. They're not. Same way, if I were to cut you right here in half and try to fold you up, they're not the same picture down here as it is up here. You're looking at like mirror images, and that doesn't happen. Even if you were to fold this over diagonally, okay, and try to like fold it over that way, this side, the bottom right corner, is not the same as the top left corner. So the reason why there is no line of symmetry is there is no line that you can draw where opposite sides are mirror images of each other. And so that's what we're going to say. There is no line we can draw where the opposite sides are mirror images. Can't do it. But that's it. That's the end of our open-ended problem and the end of practice test number 2. Thanks for watching. Don't forget to like and subscribe. See you guys later. Good luck on the test.